Welcome back to Project Pulse. In the previous lesson, we finished modeling CFETs after considering levered taxes. That's a major milestone because it means our cash flows are now lender ready and we can finally move into the debt sizing section. In this lesson, we will size and sculpt the term loan by targeting two DSCR constraints: a contracted DSCR for the stable contracted revenue portion and a merchant DSCR for the riskier merchant portion. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the model start file for free and build the model alongside me. Link is in the video description below. Let's quickly refresh what DSCR actually means, and then we will go straight into the model and build the debt sizing block. First, DSCR, or also referred to as debt service coverage ratio, is the lender's core safety metric. It measures how many times the project's cash flow covers the required debt service in a given period. Mathematically, it's simple. DSCR equals CFETs over total debt service. So if we want to maximize leverage, we sculpt the loan so debt service fits under the CFETs profile while meeting the target DSCR. Conceptually, it's a buffer. A DSCR of 1.3 means we are generating 30% more CFETs than we need to pay scheduled principal and interest. And in project finance, DSCR is what drives sculpting. Lenders size debt based on a project's ability to service it, especially in downside cases and for merchant exposure. Alright, now let's look at the specific sizing inputs we will use in this case study. For this lesson, we only care about a few inputs. First, the repayment structure. The loan is sculpted to target DSCRs, meaning we shape principal repayments to keep DSCR at or just above the threshold. Second, the merchant haircut. This is a conservative adjustment lenders apply to merchant cash flows for sizing purposes, because merchant revenues are less bankable. And third, the two DSCR targets. Contracted target DSCR of 1.3, which is on the lower end because it's a safer cash flow, and merchant or uncontracted target DSCR of 2.0, which is much higher because merchant cash flows are much more uncertain. Now let's see where those inputs are reflected in the model. Here we are back to the model checkpoint file from our previous lesson in our inputs time independent sheet. All the inputs we just discussed are reflected under our financing, tax and equity assumptions. And for today's lesson, the key fields are the contracted and uncontracted target DSCR. Those will directly shape the debt service profile we calculate. And our merchant haircut is reflected further down in our sensitivity section. Here you can see that for different cases we apply a merchant energy arbitrage or merchant auxiliary services haircut. And this haircut is typically only applied for our debt-relevant cases. In row 7 you can see our perspective. For instance, in case 8 we have a debt base case or a debt sizing case, which is why we apply a 20% merchant haircut on our arbitrage revenues. Now let's move over to our operations sheet and actually start the sizing itself. And the goal for this lesson is to compute the target debt service that the project can support each year while meeting our DSCR constraints. And the first thing we will do is pull in our contracted and uncontracted DSCR for the financing tenor. So this is going to be rather simple. For our contracted target DSCR, we pick up the input from our inputs time independent sheet in G518, hit F4 1, 2, 3 times, and we'll multiply this with our term loan tenor flag. In 517, hit F4 1, 2 times. Same goes for the uncontracted DSCR, so hit Ctrl D, grab those two formulas, drag them over, Ctrl R, and you can see we get a 1.3 DSCR for contracted CFETs as well as a 2.0 DSCR for uncontracted CFETs. Now once we have those two DSCR targets, we can pull in our contracted target debt service and uncontracted target debt service. And to do this, we will use an if-error statement because we will potentially divide by 0 in a few periods. And that is going to be the maximum of type max of either 0 because we don't want our target debt service for sizing purposes to turn negative. And comma, up here we have our contracted and uncontracted CFETs from one of our previous lessons. So we'll pick up our contracted CFETs for the contracted target debt service. And we'll divide this by our contracted target DSCR. Close parentheses, comma, if error, we want a 0, close parentheses, hit enter. Now let's drag this over, Control R. And what we can see is that in the first period, we get contracted target debt service of $6.7 million versus 8.7 of contracted CFETs. That means we have 8.7 million of cash flow available to lenders who would expect a total target debt service, meaning both principal and interest expense, of 6.7 million on a contracted basis. Now let's do the same for the uncontracted part. So hit Control D here, hit F2, and that is referring to our uncontracted CFETs as well as our uncontracted DSCR. So that should be good. Let's drag this one over, Control R. And you can see that here for the uncontracted CFETs, lenders are much more restricting. Although there is 2.7 million of uncontracted CFETs available, lenders are only willing to loan against half of this because these uncontracted CFETs are associated with much more uncertainty than our contracted CFETs. And that would technically allow us to simply take the sum of those two to determine our total target debt service. But this is not what we're going to do here, and I'm going to explain that in just a second. But what we'll do for now is create a simple linkage here to our hard-coded paste line from our copy and paste macro down here. So let's just do a linkage to row 528 and drag this one over for the total target debt service. Control R. Now, once we have implemented our full debt section, including all interest expenses, there's an important modeling issue that we will face here, which is circularity. The total target debt service ultimately drives debt size. And then our total debt size drives our interest expense. Interest expense drives our levered taxes, which we have modeled up here, because interest expenses are tax deductible and will affect levered taxes. And levered taxes feed back into our CFETs up here, which again changes our target debt service. These CFETs right here feed into the contracted and uncontracted CFETs, which then again will affect our total target debt service. So if we let everything stay fully formula driven here, Excel can get stuck in a loop or depend on iterative calculations, which is not industry best practice. And to handle that issue in a best practice way, we use a copy and paste macro down here. We calculate the target debt service once in row 527 labeled as copy, and then we paste the values as fixed numbers for the sizing step in row 528 labeled as paste. That breaks the circular reference and gives us a stable base to size our debt. So let's do exactly that here. We will take in row 527 the sum of our contracted and uncontracted target debt service. Hit enter, drag this over, Control R. And then what our macro will do conceptually is we will take this row here and we will copy this, and then we will paste special values in the row underneath. Alt-H-V-S-V for pasting special values, hit enter. And that will allow us to break the circular reference using these actual hard codes, which will then feed into our total target debt service up here. And the macro that can do this has already been set up in the model start file that you have been using from the beginning of the course. But let's still talk through how this macro actually works and how it has been implemented. So a very important step here for any copy and paste macro is that we have a delta row, which takes the absolute difference. So let's type in abs for absolute, which returns the absolute value of a number So we take 527 and subtract 528, and we would expect this delta to be 0 in each given period. Hit enter. Let's drag this over, Control R. And this is 0 right now. Let's see what happens if we actually delete our hard codes in 528. So delete all of these hard codes. And then you can see we get a macro fail because our delta is now not 0. That is, by the way, also a check, which is still turned on, our dead sizing copy and paste check. And this macro has already been set up, so you can either break it by hitting this dead sizing button here, or let's undo this, mark all of these hard codes again, delete them, and hit the master macro instead up here, which is essentially the same macro as the dead sizing. But for additional intuition, I also included the dead sizing macro button down here in the actual loan sizing section. And now let's quickly talk through how this macro has actually been set up. So what we did here is, as in our other advanced courses where we actually walk step by step through implementing such macros if you're interested. So first we named our range in 527. We mark our entire copy section from column K up to AT. And we named this target debt service copy. The row right underneath we have named target debt service paste. And then the delta sum right here feeds into our macro delta cell in H527, which we named as target debt service delta. And then we hit Alt F11 to go into our VBA. And we actually have 3 total copy and paste macros that have been implemented in this model. One for our target debt service, one for the cash sweep, and one for our DSR LC. Those 2 macros we will cover in a later lesson. But the macro that we're breaking in this lesson is the first few lines right here, and that is a do until macro. Do until our target debt service delta equals 0. And what should Excel do until this condition is fulfilled? We want to make sure that our target debt service paste value equals our target debt service copy value. So it will iteratively copy and paste row 527 into row 528 up until this delta here is 0. And since we haven't implemented any interest expense yet, it's just a simple copy and paste for one single iteration. But once we introduce interest expense, which then is tax deductible, affecting our CFETs, which then in return affect our total debt sizing, this becomes a highly iterative copy and pasting until the total debt size has been determined. Now, one more thing for this lesson is row 524, where we will have our total target debt service excluding any LC interest, which will be important for our later lesson. So what we'll take here is our total target debt service in row 522, and we'll subtract, let's scroll down all the way to the end of our debt section. We'll subtract our total interest paid for our DSCR LC, which is also based on our paste output from our macro in row 664. So let's subtract this and just make the reference for now. Drag this over, Control R, and we're getting a fail. So let's check what this is about. And this is our debt structuring check. Let's hop right here. And our debt structuring check is returning a fail because right now we're looking at the total target debt service amount excluding LC interest, which then later on feeds into a check for our final debt sizing. And since we haven't modeled any of this section so far, what we'll do for now is just turn this check off and turn it back on later once we're actually getting to this relevant section. All right, scroll back up. And one last thing regarding the macro, once you have set up the macro and named it, in our case, target debt service, so we gave it a subname, target debt service, you can then implement a button within Excel, do a right click and hit assign macro. And then we can pick the macro that we have defined in our VBA manager and assign the macro to this button, which we already did here. So if I again delete one hard code here, I can simply hit this macro and it copy and paste this value for me. Great. So at this point, we have built a target debt service profile that the project can support under our contracted and merchant constraints. And that results in a total target debt service for case 8 of $116.5 million versus total CFEDs of $226 million. And more specifically, $165.2 million during our actual debt tenor, which is only 15 years. And in the next lesson, we will pull in our interest rate assumptions down here, and then use this target debt service that we determined in this lesson to actually come up with our final term loan size in row 548. All right, guys, this was it for this lesson, and I will see you in the next lesson. See you there.